Welcome to Calculus. Today we will investigate determining if an expression is an indeterminate form at x equals c. We'll take a look at three examples. In each example, we're given an expression and then a certain value of c, and we're trying to decide whether it's one of the two main indeterminate forms. So we should say, first of all, what are those forms? When we're saying indeterminate forms, we're really talking about limits of functions. And there's two main indeterminate forms. The first is the form 0 divided by 0. If I take a limit of an expression at a certain value for x and it yields 0 over 0, I can't do anything with that. It's indeterminate. Similarly, if I come up with an expression where I take a limit of an expression and it gives me the form infinity divided by infinity, that also we would term indeterminate. Now, the reason we look for those forms is because we can evaluate those type limits using a special rule called L'Hopital's rule. So if we can identify a certain expression as having that form, all of a sudden it's eligible for a very powerful strategy of limit taking. Well, let's take a look at our three examples and decide which of the three show one of these two forms. So my first expression is 1 minus e to the power of x over x. And we're told to find what's the type form when c equals 0. So that c, that's a specific x value. And really that's the idea there is if I take the limit as x approaches the c, which in this case is 0 of this function, 1 minus e to the power of x over x, really that's where we're seeing the indeterminate form. So let's see if we can evaluate this limit. Direct substitution would give 1 minus e to the power of 0 over simply 0. So immediately the denominator attains the 0 value. For my numerator, we need to simplify this difference. So that's 1 minus e to the power of 0. Really, any base to the power of 0 is 1. And that becomes 0 over 0, which is definitely an indeterminate form. So that's the type of indeterminate form for this first example, is the 0 over 0 form. Let's take a look at our second example. So second expression is e to the power of x over x. So again, we're looking for that form of that expression when the c value is 0, when x equals 0. So the limit as x approaches 0 again of the expression e to the power of x over x. If we employ direct substitution like we did on our first example, that would be e to the power of 0 over 0. So similar to our first example, the denominator is immediately in form for 0 over 0. However, this example becomes 1 over 0, and that is not an indeterminate form because it doesn't have 0 in both the numerator denominator, nor does it have infinity in both numerator denominator. So that's the form, and what I would say there is that this is not an indeterminate form. And one thing we need to say is because it's not an indeterminate form, it's not eligible currently for use of L'Hopital's rule to take the limit. Here's our last example. I've got the natural log of x over x squared. And here we're interested in finding the form when the c value is infinity. So just as with our first two examples, we'll consider the limit as x approaches that c value of infinity for the expression natural log of x over x squared. And direct substitution, again, we don't really have access to doing that with infinity, but we could write this as a distribution of the limit to the numerator and the denominator. So the limit as x approaches infinity of natural log of x over the limit as x approaches infinity for x squared. And then we can consider those two components separately. So if I think about the natural log function, as x approaches larger and larger values to the right, the y value continues to grow, not quickly, but continues to grow forever. And so the value of this expression in my numerator, the limit as x approaches infinity of natural log of x is going to be infinity. The y value would tend towards infinity as x tended toward infinity. For my denominator, we see an even more pronounced instance of the same case. That's the quadratic function x squared. And definitely that shows very large growth, pronounced growth as x gets bigger and bigger. The y value is squaring that x value, so it's getting more and more close to infinity itself. And so this format is definitely the second of our indeterminate forms, infinity over infinity. Well, thank you for joining for this investigation of the two indeterminate forms that we can identify as precursors to eligibility for L'Hopital's rule. See you soon.